All right, we'll start small class tonight, which is good. Is there any questions about anything before we begin? No, everything's good. Okay, so we're going to continue looking at policies. In this case, we looked at airport procedures last class, and this class will look at something a little more technical, which is the same origin policy. The same origin policy you might see in other classes. I think it's 20 or 30 where you go through cross-site scripting and cross-site request forgery attacks and things like that. So we're also going to look at some of the same material, but here the emphasis is less on how the attacks work and the mechanics of them and things like that, or how you detect them. It's really on what was the policy, why is this a problem under the policy, could you fix the policy, and then it wouldn't be a problem, or would that introduce new problems? And so we'll think about it from more of a policy perspective. Okay, so the same origin policy is something that's implemented by your browser. And we use the term policy to describe it because it ultimately was decided by humans, right? So human beings sat down and they decided, developers, that we have to make decisions about how we're going to handle certain cases, and these are the decisions that we make, okay? And so there's a formal process where there's committees that are set up and things like that. And in the early days when this was developed, there wasn't all that formalism to how you make decisions. But at the end of the day, it's a policy. It's not, technically it doesn't have to be the way it is. Okay, so this is a policy that could look some way different. And there are some arguments that maybe you should have done it differently. Okay, so it just happens to have been done a particular way. All right. Okay, I'll say other stakeholders too. So stakeholders imply the idea that people have an interest in what the outcome of this is, right? So they aren't, it's not just random people and what their thoughts are on how a browser should operate. And usually policies tend to be contentious. So different stakeholders have different preferences. Their preferences are not compatible with each other, and so you have to somehow navigate them and try and balance different competing perspectives. Okay, so the same origin policy basically came about when it's kind of like when the web turned into more what we might think of as the modern web. And so you might think of the modern web, I don't know, it depends on how old you are, I guess. So you might think of it as when we went to Web 2.0. This is like way before that. This is like when the web kind of became Web 1.0 type of thing. But basically what we're going to do is we're going to move from a world where every single website or web request that you load runs in isolation. Okay, so what we want to do is we have to ask ourselves, okay, we just loaded some resource over the internet. Do we want to, for example, compose that with another resource? So should we have websites that mix resources from more than one place? We just went to a website. Should that website know about other websites that we've been to? Should that website know that we've been to this website before? Okay, so it's about mixing different resources together at the same time and having knowledge about past resources that were loaded and things like that. Basically, we're going to stop treating every web resource in isolation, and we're going to let it mix and mingle with other resources. So it concerns web resources and how they interact with other resources. Okay, and Web 2.0, this was like long before it, but it was really this idea of like kind of weaving content together from multiple resources. There were some underlying technologies that allowed it to happen. When you interact with a website, it used to be that, like say you go to your email and you have an inbox and you click the first message, it would refresh the entire page. It would try to make it look the same, like you still had the same like kind of Chrome around your inbox and things like that, but it would like refresh the entire website, and then you would be looking at your first message, and then you click to your second message, and then it'd refresh but now it's more dynamic, you know, like you just load that one little resource, you don't refresh the whole page and things like that. And the basic question is, how do you isolate resources from each other, if at all? So we have like a website. And I don't know, there's some like resource A, there's resource B. We haven't really defined what is a resource: HTML page, a JPEG, a GIF, a piece of JavaScript. You know, these are all resources. Can they see each other? Does A know that B is there? Can A read to B? Can B read to A? Can A write to B? These are the things that we need to try and decide about. So what kind of interactions are possible? And not just between A and B, but also between A and the page that loaded it. So if A is embedded in this bigger page, what about that page? Does that page have complete control over A? Can A break out of it, like break up to the larger page and control it? So these are what are the boundaries for different resources? So that's what the policy is going to define. And just to give you a hint, it's going to depend on where they come from. Okay, so if, for example, A and B come from the same place, then they will be allowed some greater interaction than if they come from completely different places. So whether they come from the same place is whether they come from the same origin. So that's the term same origin policy, which basically is going to say that we haven't defined technically what an origin is, but if two resources come from the same origin, they're going to have more permission to interact with each other than if they're from different origins. If they're from different origins, we're basically going to isolate them completely. Okay, so this came about in the 1990s. There was back then, I think, only one major browser, which was Netscape. Eventually, Microsoft came out with their competitor, Internet Explorer, around the same time. I think it might have been slightly after these policies were decided. And so two policies came out a year apart, and they're very similar. And so we'll actually talk about both of them. So we're not going to just talk about the same origin policy, but so in '94, they came out with a policy that concerns cookies. And then in 1995, they came out with the same origin policy. Which concerns resources. And the HTTP cookie policy also has the concept of an origin effectively. So there's different rules about it. And they're also very concerned about, well, what's the origin of this cookie? And does it match the current website that you're on? And if it does, then maybe we send the cookie. And if it's different, then we don't send it. So there's a lot of similarities between these two policies, but they concern different things. Okay, and then resources you can basically break into different types. So there's the actual content of the website itself. So the stuff that's in the website itself. And then there's some information that's communicated along with the website, okay? You don't see it as a user because it's not in the body of the website, but it's in the headers. And so we can call this meta information or headers or whatever you want to call it. So but I'll just call it meta information. So a cookie is not in the content of a website. So it's something that comes down with the website. It's something that when you send requests could get added to the request that you're making, but it's not inserted into the request itself. It goes along on the outside of the envelope, if you will. Okay, so it's written on the outside. So cookies are an example of this. And then content is the stuff that's on the website itself, that's in the page, that's in the, if it's a response, it's in the HTML document, for example. And roughly, we like to break content into active and passive content. So passive content is content that can't make changes to the website itself. It can't run code. It basically can be displayed, and that's the short of it. So passive content would be things like HTML, an image, say a JPEG, a movie file, MP4, that kind of thing. Active resources are resources that run code. So the most obvious one is JavaScript. That's the one that's used the most. There are some stuff that used to be used, not used so much anymore. Flash was something that we talked about, maybe 10 years ago more. Microsoft had something that was kind of like Flash called ActiveX. And there's other stuff too. The other thing too that sort of falls between the lines is CSS. So CSS files are files that tell you how to, like if you want to set all the fonts for the website, for example, or if you want to set background colors or things like that. So they are actually meant to be a passive resource. So they should just specify colors, but it turned out that there was kind of like too much permission that was given to them, and you could start doing fancier things, and there were attacks that were launched using malicious CSS files, and so now I consider them more like active. There may have been changes to it to sort of scale it back to being passive, but it's an example of something that was designed to be passive, but it ended up being too powerful. Okay, and so these policies are, well, we're talking about them in this class because there's some security goals that you want to achieve when you use these, when you set what your policy is. But security goals aren't the only consideration. So if a policy is a debate between stakeholders, you can think of the security people as one of the stakeholders, right? Or the privacy people. They want to see certain things. But then there's other people that just, like say developers, and they just want something that's easy, right? They just want it to work. They don't want to have to jump through a lot of hoops trying to get things to work. They want to be able to mash up different resources and just have them talk to each other, and everything is usable. It's easy to develop and things like that. So there's going to be tensions between them. So the security goals are just the goals that the security people want, but they're not necessarily things that were given to them, right? So we didn't necessarily achieve these goals. We had to balance these goals with the other things that we want. So if we think back to Stride, basically we have a category in tampering. That's probably the most obvious one. And basically what you want as a person who downloads a website is what you see is what was sent. And then we have concerns about privacy. So privacy in Stride falls under information disclosure. And in general, there's different things that you might want. So there's different goals you might want. You might want every interaction, like you can't, if you make 3 interactions with the web, they can't be tied together. Okay, no one knows that you're the same person that made those 3 interactions. Okay, now that turns out to be a little strong, right? Like if I go into my inbox and I type my username and password, now the website knows who I am. And I click on my first message, I don't want to type my username and password in again, right? And I click on the second, I don't want to type it in every time. I want the website to know that, oh, I'm the same person, right? I want it to be kind of sticky. So in that case, it's too strong to say, well, I want every interaction to be like sort of isolated and no one can connect them together. But you might say a more relaxed version that's closer to what you get is, all my interactions with Gmail can't be tied to my interactions with Facebook or with Twitter or something like that. So as long as I'm dealing with an origin, then those interactions are fine. But when I move across origins, I don't want them to be tied together. Okay. Now, whether that's true in practice, we'll talk about. But. So what you provide to one origin can't be seen by others. Okay, so what we'll do is we'll go through these 2 policies. So today we'll talk mostly about the cookie policy, and then next class we'll talk about the same origin policy. Okay, so what is a cookie? So a cookie is basically something that's going to try and solve that problem I just outlined. Of you're in your email and you start clicking on messages. How does Gmail know that you're the same person, right? That is clicking on it. So does anyone know the answer? How does it know? So I'm on Gmail. I logged in, put my username, password in. I'm looking at my inbox. I hit message 1. Gmail says, hey, that's the exact same person that just put their username and password in. I don't have to ask them again for their username and password. I know who it is.
I guess it maintains the session. Like when you try to log into Gmail, you initiate a session, and then that session has like cookies in it, in which it stores the information regarding you.
Okay. So we're going to call that whole thing a session. So a session is like, as long as I'm sort of on the same website doing it, my session's maintained. And it's true, cookies are somehow involved. But does anyone know how, like, what does it mean more precisely?
When we send a request to the server sends back with the cookie.
Mm-hmm.
Then, so when we click on it, so it will go with the same cookie. So it knows that, okay, this is the same user. So that cookie will be active for that particular session for this cookie.
Okay, and when you said it sends back the same cookie, like what is that? What is the cookie like?
Local reference number, so that is active for a particular period of time. So you need not have to log in. I mean, you do not have to log in every time you click something.
Okay. So what it's going to do, a cookie basically is just a number, or it's a piece of data. Let's just think of it as a number, okay? So cookie is a number. It's assigned by the server. So you don't choose it, your browser doesn't choose it, it's given to you. So I log into Gmail, and Gmail says, from now on, you will be number blah, 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 blah. And every time I go back to Gmail, I cough up that number. And as long as I continue sending that number, then it continues to believe that I'm who I am, okay? Now, what happens if you take my number?
Then I can, like, it will be like cookie stealing, like that is what we call. And then if I will try to use that cookie, then I will be able to log in your Gmail.
Yeah, exactly.
The information will be stored in that cookie, and server knows that this cookie belongs to you.
Okay. So stealing someone's cookie or that value is equivalent to hijacking their session, right? So the cookie is the value that keeps the session open. If I get your number, I'm now in your session. I notice I didn't say it's equivalent to stealing your username password, but it's very close, right? It's a little weaker because sometimes now, because session hijacking is known to be easier than stealing a username password. For example, if I steal your username password, I can change your password, right? Maybe there's some like email loop or something like that, but in general I could. Usually with a session, I couldn't do that. I could read all your emails and probably delete emails, but as soon as I went to say change your password, it might ask me for your password again. And then I don't know my password, or your password in this case. So some sort of sensitive administrative tasks require a re-authentication because it's known that it's a little easier to lift someone's session than it is to lift their password. But having a session is almost equivalent to having someone's password. Now, sessions also don't live forever, right? So if I steal your session, but I don't get around to using it for a week, right? Then it might be too late. So how long a session lasts is basically, it's kind of a song and dance between your browser and the server, but it's mostly dictated by the server. So the server just decides that after a certain amount of time, I'm going to stop honoring this cookie. And so when you, for example, sign out of a service, you don't actually like delete your cookie or reset it or anything like that. The only thing that changes is that you send a message to Google saying, hey, don't accept this cookie anymore. Your computer will still have it. It will keep sending it. It doesn't know that you signed out. It's just a convention that the server is using to agree not to honor that cookie anymore.
So what is the difference between session and connection?
So a session is like something that's governed by a cookie, and connection I would think of as like an internet, more like a network level thing. So like maybe a way of distinguishing them would be, what if I logged into Gmail and then I left campus and I sit down on my train and I'm on my cell phone, right? So I'm on a completely different internet connection, different network, different service provider, different IP address. Does Gmail still know that I'm me, or are they going to ask for my username password, right? And so if your session normally you could change networks, right? Because like even if you're walking around the university, you're changing Wi-Fi routers and things like that, right? And so, but yeah, so a session has the power to, like, it makes no reference at all to your IP address or your actual connection itself. So by default, out of the box, your session will not terminate when your connection changes. Now, that said, like Gmail or whoever, they can certainly look at your connection details. And they might make a decision to terminate your session based on the changing of your network details, right? So sometimes if they don't recognize your computer or something, your device, like it asks for some IDs about your device and things like that, and it's like, oh, this is a new device, then it might say we're going to cancel it. If my IP address completely changed, if it changes from Concordia, which is in Montreal, to Bell, which is like in Montreal-ish, to Google might not be that concerned, right? But if it changes from an IP address in Montreal and then 2 seconds later it's an IP address somewhere else, China, for example, then they might terminate the connection, right? They might think it's unreasonable. And it's not a big onus, you just have to re-put in your username password, right? So yeah, so the websites may choose to do it anyways, but by default your session outlasts your connection. Okay, so let's put some of this information down. Okay, so cookies are just numbers or values. They usually are given a name just so that if you get 5 cookies, you can tell them apart. The fancy way of saying this is we call this a key, but I don't use that because you might think it's a cryptographic key. It's not. So they call them key value pairs. It's just a data structure that's used in computer science a lot. But basically, it's a name or a tag or a key, and then the actual number itself. So like SID would be a typical name. That stands for session ID, right? So SID or SSID or Google _SSID or something like that. That would be the name of it. And then the value they give you would be the value. And if I looked at someone else's computer, I would see, oh, they have a cookie with the same name, but the number is different, right? So that's how it would work. So your browser remembers it. And your browser will staple it. So this is where the policy kicks in. Will staple. Staple means just like put it together, not literally. But it will staple that information with the origin of the site that gave you the cookie. And we'll go into a little bit of detail of what exactly an origin is. But for now, just think of it as like gmail.com as opposed to facebook.com. Those are different origins. But is images.google.com the same origin as google.com? That's like where we'll have to just write down some policies about. Okay, and then I mentioned this earlier, but I'll just repeat it, the cookie is not in the body of the HTML, it's in the header of the requests and the responses that are going back and forth. So of the packets, so they could be HTTP packets, that's what we'll focus on. You could use cookies in other protocols other than HTTP. The same as what token?
Bearer token.
Okay, yeah. So bearer token is a more general term, which means I authenticate you based on what you show me. So a cookie is an example of a bearer token. Yeah. So yeah, if I show up, that term comes actually from finance. So like, let's say there were shares of a company and Google issued a bunch of shares. You used to have like a certificate that's on paper. And if I want to sell my shares to you, I just give you the certificate. So that's a bearer instrument because if you want to show up at a shareholder meeting, you just bring your piece of paper and say, it's mine, right? So it's whoever shows it to you, you believe that they're the person that it was given to. Yeah. And so cookies work on the same principle. They don't try to authenticate who's behind it. It's good enough if you know that value, then I believe that you are the person that logged in and I assign that value to. No problem. Another thing too, just I'll mention it probably later, but in case I forget, cookies aren't just used for like sessions. So sessions are like the main thing that we think of from a security perspective, but they're used for all sorts of other things. Like say you go to a website and you change it from French to English. I do that a lot living in Quebec. That website might remember that I prefer the English one next time I go back, okay? And I didn't log in, I didn't create a username password, I don't have a quote unquote session, it's just, it's set it with a cookie, and every time I go back to the website, my browser sends that cookie and it recognizes that I want the English version instead of the French version. So cookies are used, for the functionality of the web in lots of ways other than just sessions and authentication and that type of thing. Okay, so let's just sort of draw out a typical interaction for this. This will be for a session ID. Okay, so here's Alice. Alice just got a brand new computer, went to the Apple Store, turning it on for the very first time. It's completely blank, never been on the web before, never opened Safari, the browser that she's about to use. She has no cookies, nothing. It's just a fresh computer. Computer doesn't know anything, okay? So she goes to Safari, she opens it, she types in google.com, presses enter. What happens? So the first thing that happens is that she'll, first off, her browser basically wants to send a request to google.com and say, give me index.html, right? And so in order to do that, she has to go to DNS and get the IP address, because the web doesn't run on actual google.com, it runs on IP addresses. But the IP address has nothing to do with cookies, but I'll just put it in here anyway. Okay, so now she has the IP, so she knows where this server is in IP space. So then she sends her request to it. Then what Google will do is, even if she doesn't log in, they just do it anyway because they like to track people. So what they'll do is they'll say, hey, you don't have a cookie, or it doesn't seem like you have a cookie. And by the way, if you want the experience of turning on a computer for the very first time, you can open private browser mode. So that's actually what that does at a technical level, is it gives you like a fresh browser, no cookies, just like you bought your computer for the same time. If you use private browser mode, it will accept cookies. So it's not the same as turning cookies off. It's just starting with like a fresh identity with no cookies yet. But then as you use it, it will accumulate cookies, and then when you close that session, it will forget all of your cookies basically. And then if you open a new session, then you'll start fresh again. So yeah. Anyway, so Alice either bought a new computer or she opened private browser mode. She doesn't have a cookie yet. So Google's the one that's going to set the cookie. So this is where sometimes there's some confusion. So people think that cookies are set by the user in the browser. They're not. They're given to you by Google, okay? So Google will send a response. The response will be, the basic Google landing page, with the search bar and all that. And apparently they only ever have 14 words on that page or something. So if they add a new word, they have to take another word off or something. I don't know. But anyway, so they send the actual HTML page for Google. Plus it might load some images and load a couple more resources that we'll talk about later. And then in terms of cookies, what it's going to do is it's going to append in the header. So I'm going to redraw this so it's more clear that it's happening in the header. So you have the response here. And then in the kind of like the header of the packet, it will say, okay, I want to set a cookie. Okay. So I'm going to set cookie. And there's a bit of information that goes into it, but we'll just concern ourselves for now with two pieces, and then later I'll show you actual cookies and the other stuff that's in them. So basically we need a name, so we'll call it SSID. Although this isn't, she didn't log in, so maybe that's a little misleading. SSID usually stands for Secure Session ID. But anyways, Google's hoping that she creates an account or logs in, and then they'll just keep her SSID. But anyways, so they can assign a cookie with any name, and then they just give it a value like 55. Okay. Now, if you went back to Google and said, "Hi, my SSID is 55," then they'll think you're Alice, right? So that's what it means to hijack a session. And so you might note that 55 is a ridiculously small number because I could just guess it. So one way of doing session hijacking is just to try every number. So if you notice that someone's using short session IDs, you can just try random numbers, and then eventually you might grab someone's session, right? You can grab session IDs if they're not over HTTPS, then they're in the clear, so you just grab it and then you log in. The biggest breakthrough that happened is everyone knew in principle that session IDs were set. Usually the web didn't used to run on HTTPS, right? So you would go to Facebook, like a big website, like in the early days of Facebook, and they would say, what's your username password over HTTPS? And you would send your password in. But then they would turn you back to HTTP because when you're downloading your friends' photos and all of that stuff, that's a lot of data and they didn't want to encrypt it all, okay? But what they didn't do, or what this whole premise is, every time you go back to Facebook, you're sending this session ID, right? And that's not going over HTTPS. So even though it protected your password, right, then it redirected you to HTTP, and now you continue sending the session ID, but it's in the clear text. So people understood that if you could grab that session ID, then you could log in effectively as that user on Facebook. The problem is that it was just like, how are you going to do that? Like if I want to attack you, like what, you know, how am I going to get on your connection? How am I going to become a man in the middle for your connection? And so it was like one of those things that was possible in theory, but it was just like kind of too hard to orchestrate. Then there was a developer who came out with like a super simple browser extension. You didn't even have to install anything. It was called Firesheep. You would just put it in your browser. And if you were on Wi-Fi, there is a way to put yourself in the middle of a Wi-Fi connection. Just the way that the Wi-Fi protocols worked, there was a way to basically get all the traffic routed through you. And normally this wouldn't be a problem because it would all be encrypted anyways. But in this case, it wasn't. Like the websites weren't using HTTPS, so they weren't end-to-end encrypted. And it was like a routing trick, basically, where you just got everyone routed through you. The Wi-Fi itself has some encryption, but it basically ends at the router. So that didn't apply. That's like just link-based encryption. And so anyways, it would get everyone routed through you. It would look at common services. So it was like programmed for Facebook, Twitter, like MySpace, or like whatever was popular back then. And it would just like literally pop up with everyone that was on your Wi-Fi network, and you just like double click their identity, and then you would be like logged into their Facebook. So you could just go into Starbucks, open the extension, you would just see this list pop up with other people in Starbucks. It would show you like their profile picture from their Facebook account. You double click it, and then boom, you're now like logged in. And so that scared people. So like for 10, 15 years, everyone knew it was possible, but it wasn't until someone like actually made it that simple that anyone could do it and didn't have to know anything to do it, then that really got people to change. And so within 6 months, everyone was on HTTPS, like just throughout the website, not just on that login page. But anyways, okay. So what Google does here is they set the cookie 55. Okay. Okay, so this is going to be a unique number, so they're only going to assign it to Alice, and it should be too large to guess. Otherwise, you could do session hijacking. Okay, and then the other question you might, like the Firesheep raises is this value encrypted or not? So how do I know whether this session ID is being encrypted end-to-end or not? And it basically is, did the request or the response come over HTTP? So like when I loaded the page, am I looking at http://google.com, or am I looking at HTTPS with the lock? If I'm looking at an HTTP page, then it was not encrypted. and any man in the middle could session hijack. If I'm looking at an HTTPS page, then I know that the content of the website was encrypted, right? So the Gmail landing page and the images and all that stuff, right? It was all, that stuff was all encrypted. But the cookie's not in the content of the website, right? The cookie's on the outside of the envelope. It's in the headers. So are headers covered, are they encrypted with HTTPS or not? So you might not know the answer to it, but it's something that you should, give pause and think, oh, maybe they aren't because they're in the header. But the answer is that yes, they are. So HTTPS encryption includes the headers as well as the actual content or the body. Basically, the only thing that's outside of the HTTPS envelope is the IP address of where you're going. But the website that you request, like the actual URL that you request, that's in the envelope. That's also a header. And then your cookie value and things like that are also in the envelope. So they'll be in the HTTPS envelope. So there's different envelopes for different things. But anyway, so the answer here is yes. Headers are covered by encryption. Okay, then what will happen is you set the cookie. Okay, so what is it that Google wants to happen here? Okay, so they're saying this is the cookie value 55. Okay, they give it to Alice. What they want is they want Alice's browser to remember it. Okay, so they're basically saying Alice's browser, we're talking to you, we want you to write this number down. And then every time you come back to us, we want you to send this number. Then I know it's the same person, then I can connect the multiple sessions together. So Alice's browser will do this, where it has a little table. And so it will say, okay, we have google.com, and we have this cookie SSID equals 55. So this is called the origin. It's where we got the cookie from. This is the cookie value itself. And yeah. And then this whole thing is called a cookie jar. Okay, now let's say that Alice then clicks on something and she sends 55 back. Okay, now Google knows what? They know it's the same user. Right? There's only one problem. How does Google remember? I mean, they have millions of users, so they send 55 to Alice. Someone comes back with 55. How do they remember? Right? And so Google also needs to have a sort of competing database. They have to have a cookie kind of jar themselves where they're writing down who they gave these cookies out to. Okay? So Google will have they'll be like, okay, this is the person and this is the cookie that we gave them to. And so they gave SSID equals 55 out to Alice. They don't know Alice, they don't know anything about her, she hasn't logged in or anything like that. So for now, they'll just attach it to like her IP address and maybe whatever else they can glean from it, okay? And so if they ever see this thing come back, say from a different IP address, they'll say, aha, that's the same person. They want the page in English, not in French. Even though they're coming from a different IP address, we'll give it to them in English. So that's the other thing they might have is like what their preference is itself. So the preference could either be in the database itself. So they're just like, here's 55, here's our profile about the user. They want it in English. Last time they asked for the font size to be 2 times bigger, whatever, blah, blah, blah. And then they can keep that in their database. The other thing that's usually easier to do is just to put it in the cookie itself. So the cookie will have like lang, and then it'll just be equal English or equal French, and they'll give that same value out to multiple users depending on what it is. So you can store information if it's not sensitive private information. You can store it in the cookie itself, or you can have a database where you're using the cookie to look up the information that you want about the particular user.
Is it possible to like reuse the cookie? For example, if the session is timed out, and so obviously that cookie just gets free. So is it possible that server assign that cookie in new session, or how does it work?
Yeah. So usually when we say it's unique, we it's not that the server remembers every cookie it assigned previously. It usually just picks them at random, but it picks them from a large enough set that the probability it would assign two cookies, either it could be the same user at both at the same time, or a user like that previously had the cookie that now value is being assigned to a new user. The probability would be like low, like once in the lifetime of the universe low. And so basically it wouldn't happen unless if there was some sort of software implementation flaw. And then in that case, your old cookie would log you into the new session account. Yeah. And so I feel like maybe in the early days of web, you would sometimes like go to a website and somehow be logged in as someone else, probably for this reason, that their cookies weren't big enough. I feel like that was an experience that I maybe had when I was a kid, but yeah. Okay, so now let's say Alice comes back. I'll just draw it down here because this diagram's getting too much text around it. Okay, so now Alice is going to log into Google. So she sends her username, password. She sends a request. The request includes her username, password. She's going to log in. She already has the cookie, even though she wasn't logged in, so she might as well send it anyways, or she doesn't have a choice. Her browser will send it. So she sends it along in the header of the request. And then Google will send its its response back. And it will check basically the username password. So it's going to take the username password over to its password database. And now we can think of the password database as not just having a user field and a password field, but now it has an SSID field as well. Okay, so it will find the user, Alice. It will check whether the hash of the password matches the hash that it has on file. And assuming it is equal, it will say, okay, from now on you will be 55. Okay, that was your session ID, and so you'll be 55. And now if you come back, I assume I can reverse index into this table. You come back with the user SSID 55. I'll look it up in this table and I'll see, oh, 55 belongs to this particular user. And so then I'll know that it's this user, and I'll just log them in or give them the first inbox out of this user's inbox. Okay, so then you ask for a message. And you still have your SSID set. Then what it will do is it will take this SID. It will walk it over to this table, it will find it, and then it will say, okay, I know who this user is, and so then it will give you, the inbox equals 1 for the user that corresponds to this. Okay, questions about this?
value is plain text or it's also?
Yeah, so the cookie value itself is in plain text. But it's, sorry, I'm just going to make a copy of this here before I forget. So it got this SSID in both of these from looking at this table. Okay, yeah, so the SSID is stored in plain text. And you might say, so let's go back to the question of why do we hash the password? We hash the password because we're concerned about the whole thing leaking, right? And that does apply to SSIDs as well. So if the whole thing leaked, then all the SIDs would be out there and then someone could session hijack you. But the reason that we don't protect it to the same extent is that, well, first off, I shouldn't say that they aren't hashed. I don't know, like, it's a question that, like, I don't know the answer to. Maybe they do hash them. In fact, it would actually be a good policy. And so I shouldn't say for sure that they aren't. But anyways, because they tend to be shorter lived, there isn't the strong concern about it. So a password database leaks and then it still has monetary value 3 months later, 6 months later, because no one changes their password very often. But SSIDs would all be like invalid by then. So yeah, so that's why. It's also, you can't really reset a password for a user. So if the website noticed that it got leaked, they can't go and change everyone's password because then no one could log in. But they could go and delete everyone's SSID, and then it just means that next time they came back, they would have to log in again as well. So yeah, so SIDs are a little easier to control a leakage of. A, they're short-lived. B, you can just cancel them all. And at worst, the user has to do an extra login, but it's not like they can't log in. Yeah. So anyway, so that's why they would be lighter protected, but there isn't any reason why you wouldn't hash them. You could hash them if you wanted. Yeah. Okay. So the last thing is expiry. So we did talk about session IDs expiring and things like that. So mechanically, you look at this picture. What is an expiration? Is an expiration that something that happens client side, or is it something that happens server side? Server side. And like okay, so when I think of how do you stop a session? So let's put it that way. I want my session to be over. Can I as the end user choose for my session to be over?
When you log out.
Okay, so I'm going to do something like log out. Okay, so that's something. So first off, I'm at the whim of Google providing me that option, right? So maybe they provide it, maybe they don't, but we'll assume that they do. So when I click the logout button, what happens in this picture? So I send a request basically saying, hey, log out, right? So Google knows now that I clicked on it and I want to log it out. Is that something, do I then go change my browser? Or does the Google change their website?
Google expires the token that was given.
Okay, right. Okay, so expiration happens server side. So if I want, for example, to log out, okay, so basically I'm going to send a request to Google basically saying, hey, you have this cookie stored for me, 55, I don't want you to use it anymore. Okay, now Google could still use it to track me. Okay, so they're basic, but they're not going to log me in automatically. Okay, now what about my browser? So I log out, now I'm logged out, right? Does my browser keep sending 55 to Google even though I logged out?
Hopefully not.
Hopefully not. But it does. Okay, so there's no There's nothing about the logging out process that impacts my browser at all. Okay. Now, what if I want to remove 55 from my browser? Can I do that? Okay. So I can actually do that at any time, right? So you could have a user that is like, let me put it in the diagram form. You could delete this value without deleting this value. Okay? What that means is that you're still technically logged in as far as Google's concerned. They just haven't seen you in a while because nobody's showing up with this value. And maybe you get a new cookie assigned to you or something when you log in again. I don't know. Okay? Similarly, your browser could keep sending this value, and Google has deleted this value. Okay? In this case, they probably don't strictly delete it because they're happy, for privacy reasons, just to track you and things like that. So they're happy that your browser keeps sending this thing along, and then they're like, oh, I know it's you, but I'm going to ask you your username password anyway because you asked me to, kind of thing. So anyway, so that's another possibility as well. So you're free to delete this at any time, but it doesn't actually log you out of the website. It's a different concept. And just to note that this table is completely under your control. Okay, this is on your computer. You can do whatever you want. If you want to change the session ID from 55 to 65, you can do it. If you want to delete all your cookies, you can delete all your cookies. If you want to say, hey, back here when Google tried to set this cookie, don't do it, right? If you ever get a set cookie request from google.com, don't do it. You can do it for Facebook or Twitter, that's fine, but I don't want any cookies from Google, okay? Then your browser just won't put it in, okay? So these are the things that the usability study that you did, Ghostery, and they give you some insight into the different cookies that are used for tracing you, and there are other extensions too that are more targeted at you controlling. I forget how much functionality they have around that in those tools, but there are other tools too that you can basically set up different rules that you want, like never allow cookies from this site or always allow cookies from this site. And browsers now have that built in, like Safari as well. Okay. Cookies also sometimes have an expiry date, and then that's basically when your browser decides to delete it, right? But the expiry date is set by the website. So when the website gives it to you, the website may say, oh, I want this cookie to expire. Like sometimes the website is concerned about session hijacking, right? So they don't want your cookie sticking around forever. So the website could say, hey, send this cookie for 30 days and then delete it. Sometimes it will say every time the browser window closes, delete the cookie. So that would be like a session long cookie. So it's either attached to the session, the browser session, or it's attached to some sort of time delay as well. So let's say user can clear cookie at any time. Website can also set an expiration. Okay, let me show you what a cookie looks like, and then we'll talk about how they're used from a privacy perspective to trace you. So I used to always go to dictionary.com because it was like the worst website for cookies, but I think last year I tried it and they had cleaned it up a lot, and so they weren't sending a lot of cookies. But let's just take a look. sorry, I'm not seeing what I want. Okay, so okay, so we can see basically all the cookies that came down with it. They're sorted by origin. So here, it's maybe a little small, but hopefully you can see it. So there's spanids.dictionary.com, and then there's www.dictionary.com. These are considered different origins, so they're assigned different labels in your cookie jar. For www.dictionary.com, these are the actual cookies themselves. So the website set a bunch of cookies, not just one. These are the names that they gave it. So SID is probably my session ID, right? So if I changed a bunch of preferences or logged in and you are watching this YouTube video and type this value in for yourself, you could hijack my session. And then this stuff is probably like page views is like one, like some of them you can sort of tell, but these things are probably like not that security sensitive. You'll also note that there's a secure flag here that's set for SID and BID, but not set for anything else. BID is, I think, usually browser ID, but anyways. Okay, so we have the name of the cookie, the key of the cookie. We have the value that's set, the number that's actually the cookie. We have the domain that set it. There's a slight difference between .dictionary and www that we'll talk about. There's a path variable. There's the expiry date, so this is date-based. There's the size of the cookie itself. There's two flags, secure and HTTP, and same site we won't talk about. So I'll walk through each of these one by one. Perfect, thanks. Okay, before I walk through them all too, I just want to experiment with a few things. So your browser now has lots of privacy functionality that's built into it. So there's cross-site, actually now it basically has one functionality in Safari. So I think clicking this button does more than one thing. It used to be broken down into different buttons. So there was something called the do not track header that you could insert or not insert. And then there's cross-site cookies as well. So a cross-site cookie, we haven't really talked about origin yet, but it's going to be, is your browser going to send Facebook cookies when you're going to dictionary.com kind of thing, okay? So I had that turned off, right? But now what we can do is we can reload the page with it, or I had it turned on rather, and now we can reload it with it turned off and see if there's any difference. So I don't see any difference. Does anyone know like a super spammy website? Facts.com. Facts. FR. ACDS. Like that? Is this right? Okay.
You can try a website where you catch the live events, like UFC fights.
Yeah. I was going to look for like some pirate like website. I'm scared that like some porn's going to show up on the screen or something. So. Okay. Anyway, so this website is pretty good. So that you can see they have some Google stuff. Actually, it is an actual Google website. So that's fine. More chairs something. So we expect cookies from Google since it's a Google website. But it does have Amazon, at least as a domain that's listed, although it looks like it's not setting cookies for it. Here, let me just try and find something good. So the site's okay. Usually these like review sites themselves are super scanny. This one's pretty clean. Maybe torrent sites are clean now. No, I'm just clicking on random stuff. That's dangerous. Okay, well anyways, I was hoping to demo it. Next year I'll do my homework and have a website that's good to go. But anyway, sometimes you see that this cookie stuff just goes crazy and you get all sorts of cookies from all sorts of places. Normally it's because just looking at the other settings. Normally it's just for tracking information, right? So they want to track you as you go around to different websites, and they'll set all sorts of tracking cookies. And so let's take a break. I'm going to play around with this a bit more. I'll see if I can find a better demo site, and then I'll go through that what all the values are in a cookie, and I'll show you how tracking works as well. ESPN is relatively dirty, I guess. You can see that they're sending a lot of sites for ESPN itself. There are some other websites that would like cookies. My browser is not sending them. Why is my browser not sending it? It's because I have this prevent cross-site tracking on. If I unclick it and reload the page, hopefully I don't have to clear my cache to do this. It should start sending all of these now. And I'm going to be very careful so that the video doesn't have my Twitter or Google session IDs in it. So you can see that for some of these third-party sites, the cookies now are actually being sent. Okay, so what we have is, because we were on ESPN, we sometimes call this the first-party cookies. And then everything else is a third-party cookie. That term sometimes means something a little more specific. It has to do with which website set the cookie. So if you go to ESPN, you don't expect that Google's going to set a cookie, okay? But if you go to ESPN and you load a resource over Google and then it ends up sending a Google cookie that was set by Google, like when you were actually at google.com, then that's different. So sometimes there's a distinction there, but for the purposes of this class, I'm going to simplify things and we can just call these third-party cookies. Okay, and then for the actual, for the ESPN cookies, we have a name. We have the actual value of the cookie itself. We have the origin that set it. There's this path variable. And these two things are going to dictate when that cookie is sent. So your browser is going to see this sitting in its cookie jar, and you go back to ESPN, it's going to say, okay, should I send this cookie or not? And it's going to use these two variables essentially to decide whether to send. So browser decides to send cookie or not. Then we have the expiration. And so the expiration, remember, you can override yourself. So you can delete it anytime you want, but if you don't do anything, this is what the browser is going to do. But this is set by the website. So the website decided how long to have these things last. So you can see some of them will last as long as the session. So if I reset my computer, then this thing will disappear. And then some of them have like a time-based extension. So some of them are pretty long-lived. You know, so this one, for example, is going to be alive to 2042. I hope I'm not using the same browser in 2042. And then other ones have like kind of more reasonable kind of dates associated with them. You have a size, that's fine, whatever. And then you have two flags, secure and HTTP only. So these are our security flags. Okay, let's do the two flags. So there's one called secure and there's one called HTTP only. Anyone want to either knows what these are or want to guess? Okay, so secure is basically going to say you should only send this cookie if it's an HTTPS connection. If it's not an HTTPS connection, don't send it, okay? So the website is setting this flag for that cookie and giving it to the browser. And so the browser, when it does its check, it's going to say, okay, should I send this cookie or not? It's going to ask, well, is it going over HTTPS as opposed to HTTP only? Let me phrase it differently. Okay, then what's HTTP only? Probably the worst name ever, given the, so does that mean you just send it over HTTP? Like, don't send it over HTTPS? So if you want it secure, you only send it over HTTPS. If you don't mark any flag, it can go over HTTP or HTTPS, HTTP only. Sounds reasonable, but why would you ever want to send a cookie only over HTTP? Okay, so this does not refer to that, but you would think it, you know, given the definition of the other one. HTTP only, you actually, if you went over HTTPS, it would still send the cookie. So the cookie has nothing to do, or the name of it has nothing to do with HTTP as opposed to HTTPS. It will send it in either case. What it has to do with is HTTP/HTTPS as opposed to something else. So what else could there be that may open a connection and then the browser has to decide whether to send a cookie. And the answer is JavaScript. So if JavaScript opens a connection, it's considered not an HTTP connection. And what will happen is you can set your cookie to not be sent in that circumstance. So if it originates from a browser request, from a downloaded page, user request, or a resource that the page is asking to be loaded, then you send it. But if JavaScript opens up a connection, then you don't send it. And I forget the name. There's a special name for that tunnel that it opens, and basically it's not going to send it in that circumstance. And so it was motivated like back when you would have a website and you would have some malicious JavaScript, and it's basically trying to hijack cookies. But anyways, it's not really used that much anymore. But let me put it. So I'll put it in the negative. So do not send. And it's a reminder to myself to look up the proper name. So you can use JavaScript to load HTTPS resources. So you can use JavaScript to say, go grab this ad and grab it over HTTPS. So I don't want to give you the impression that just because JavaScript made the decision to go grab this resource that it won't go over. It's when JavaScript itself creates the socket itself, that's a different kind of socket than HTTP. And in that case, it will get set. As you can see, none of the websites use it. And if I showed you Google or Twitter or some major website that I'm scared to show you, you'll see that they don't really use that setting either. So secure is the more important thing to worry about. Now, why don't you just mark everything secure?
Not all sensitive information.
Yeah, so it could be not sensitive. So you can even look at the names here and see country, CA, so you can see like some stuff that you can sort of infer what it is. So none of this stuff has to do with sessions. You can see that the two that are marked secure, let's see what they are. In this case, actually, it's not that. It's client type HTML5 client version 4.5.0. Anyways, I don't expect that ESPN, I didn't log into the website, I don't have an account there. So I don't know that any of these things are session IDs. Once again, I could show you Twitter or Google, you could see that information, but then I would give my session ID out to everyone. But anyways, yeah, so normally you would see this flag attached to things like session IDs. Okay, now let's talk about this field, so the domain field. So this will bring us back to the same origin policy. So the domain use field is used twice. One is it's used when the cookie is set. And then it's referenced again when you send the cookie. So it's sometimes a little confusing. But basically what ends up, you'll see that there's even a slight difference between some of them are .espn.com and some of them are www.espn.com. The difference there is what got written down there was decided by the website that I went and visited, which was, I guess it was www.espn.com. So that website decided what to write down here. And later when I go back to ESPN's website, my browser is going to compare what was written there to what website I'm trying to visit, and it's going to try and decide whether it should send the cookie or not. Okay? So there's going to be different rules about what values are you allowed to write down here. And then when that gets compared to the website that you're visiting, then is it considered a match, yes or no? Okay, so there's sort of two things that you have to keep track of, but it will be easy to understand it. Just let me just write it out with some examples. So let's say that you go and visit my website. Actually, let's say that you just go to encs.concordia.ca, ENCS is what we were called before, and all the, I should update these examples, but anyways, all our personal websites are on this domain. That's why I use it, but we're obviously Gina Cody now. So let's say that this is the setting site, okay? Okay, so I go to this site, I visit it, and this site wants to set a cookie. Then the question is, what are they allowed to say in that domain field for cookies that they set? Are they allowed to, for example, set a cookie that should always be set when I visit google.com, right? The answer to that probably is no, right? So there's going to be some rules about what domains they're allowed to set in the domain field. And then we'll just double check, what does that mean if I go to a different website that's not this website? Is that considered a match or not? Okay. So the easiest thing that you are allowed to do is you can set your cookie to the exact same domain. Okay, so this is allowed, so this is the same domain, or same origin. Let me use the term domain, because origin site's just minorly slightly different. Okay, so I am allowed to set a cookie here, and basically that tells the browser that if the person comes back and they're visiting this exact domain, then send the cookie, otherwise don't send the cookie, okay? So let's say later, user goes to images.concordia.ca. Do we send this cookie or not? So the domain was encs.concordia.com. They set the domain of the cookie as encs.concordia.ca. Now the user's on images.concordia.ca. Should we send that cookie or not? Okay, so this is a policy. So you might say yes, you might say no. So lots of you are nodding your head. So why should this cookie go along to this website?
If it's a part of ENCS Concordia, then yes. Otherwise, he doesn't have to log in to all the internet websites that is happening to that particular.
Okay. So, but what is it about this domain that makes you think that these two match? It's because they both end in .ca, right? So like yahoo.ca, google.ca, they should all match, right? No? Okay. So what is it? Okay, so it's the concordia.ca. So you notice that they both have the same super domain, right? Okay, so if you want these two to match, you can do it. Okay, so it's very natural that a cookie set by encs.concordia.ca should match to images.concordia.ca because they're both part of concordia.ca. If we go all the way up to .ca, that seems unreasonable. Okay, all right. Now, if I want to specify that my cookie that I'm setting from encs.concordia.ca should match to anything.concordia.ca, what would I say normally? Yeah, so I would put like a wildcard or something like that. So this isn't the notation that's actually used in cookies, but I'll use it. So I maybe wasn't clear on what's going on. So there's different things that I can set. So I could set it as .concordia.ca. Okay, so I'm allowed to do that set. And if I do that set, then when the user goes to images.concordia.ca, it will match, okay? So that is. But if I set it instead as encs.concordia.ca, I'm actually being very strict, and I'm saying, actually, I want this cookie specifically for encs.ca. I don't want it, if you go to images.ca, you won't send that cookie along, okay? Now, I could set it also with, let's say I go to users.encs.concordia .ca. Would that pass or not? And by the strict policy, the answer is no. So this is still set to encs.ca. It turns out that you can't really do this anymore. But anyways, let's just roll with the kind of the philosophy behind it. But what I could do is I could instead set it to something more specific than me. So I could set it to .encs.concordia.ca. Then users.concordia.ca, .encs.concordia.ca would match. Okay, so basically if I'm encs.concordia.ca, I kind of have three options. Option one is I can set it to myself exactly. I can set it to a super domain of myself, so it matches all super domains. Then it's going to be a wildcard, so I can't say only match images but don't match people.concordia. It's all or nothing, okay? So I can set it to a super domain, but I can't go all the way up to a top level domain. Okay, and there's no philosophical reason. It's just that it's stupid. Like there's no reason to do it, and it's going to get you into a lot of security trouble. So it's an override that the browser says, oh, that's something you can't do. So if I try to set it to .ca, then this is disallowed by policy. I can also set it to specific subdomains too. So if I want to set it to users.encs.ca, I could do that, and then it would only match to users.encs.ca. So yeah, anyways, I won't go through every permutation, but that's fine. Now here's another one that let's say I set it to encs. I am encs.concordia.ca. I set it exactly to encs.concordia.ca. What about www.encs.concordia.ca? Is that the same as encs.concordia.ca? So people are nodding their heads, people are shaking their heads. That's good. It's contentious. What do you think? So remember, this is a policy, so you can decide whatever you want. www is actually just treated as a subdomain. So as far as the web's concerned, there's nothing special about www that's any different than users or images.concordia.ca. It's just another subdomain. It just became convention that when you set up a website, that you would put it at the www subdomain of your domain, and you would kind of save your domain for because you use your domain in your email, and you use your domain, for FTP or whatever, and so you would kind of be like, my FTP server's at ftp.pubspy.com, but my website's at www.pubspy.com, and it just kind of keeps everything organized. But then, for usability reasons, why type in the www, since no one uses FTP anymore, and everyone knows the difference between email, and there's nothing else you're putting into a browser. There's no other reason you're going to a domain really than is to get the website itself. So then by convention, people just drop the www, or now both of them are supported, okay? But when it comes to DNS, www is given a different, it's a different entry than just the root domain, okay? So if you want them to point at the same server, you actually have to manually add www to your DNS record. So it's very common actually that you go to a website and it's misconfigured between the www version, or HTTPS works on one and it doesn't work on the other, because, yeah, anyways, it gets complicated. But as far as cookies are concerned as well, www is a distinct domain. So you can see here that there's actually 3 different domains that are being set. So because it's being set from www.espn.ca, the website's allowed to go up a level. So they go up the level to star.encs.com, which they denote as just a dot, okay? Or sometimes they set it to the exact domain. So you can see www.espn. And then this cookie's kind of weird. I don't know if you can see, it's kind of small, but it's actually .www So it would be a subdomain of www.espn. Probably that's a misconfiguration because you normally wouldn't do images.www.espn.com. You would probably do just images.espn.com. But anyways, you can see that is allowed in order for you to do. Okay, and then if you are encs.concordia.ca, can you set a cookie for facebook.com? And the answer is no. So it's a totally different domain, right? Mismatched domain. Okay, so this is important because you sometimes want, you want to track users. Like when a user loads a page and then they start loading images, you want to make sure that they're the same user, but you have your images on a different server. It's at a different IP address. Therefore, you give it a different domain. And so you want the cookie to cut across domains. Other times you don't want it, right? Like you don't want your mail.google.com mixed in with your images.google.com or something like that. And so there's different reasons to do it. What tends to happen with amateur developers is they set it the most restrictive to start, which is to the exact domain. Then when they get errors like trying to track things, maybe more with same origin, like where they're trying to load resources, it's not working, then they start putting in the wildcard like domains and scoping it to like the widest possible so that everything can come together and be considered same origin. Okay, the other thing that was here that it doesn't use, it almost never is used either. It's very rare to see, but you see that there is a path field here as well. So for example, let's say you go to my website. I could use the path field to say, hey, this cookie should only match this particular path, okay? So let's say I set it from this site and I specify ~Clark as the path. Then if you go over to users.concordia.ca/immanon, then it will reject, or it won't send the cookie along because it will say, well, yeah, they are at the same domain, but the path doesn't match. Okay, so you could scope a cookie to just an actual page within a domain, not a domain. But anyways, this is very uncommon that you would do this. So if you instead set path to just /, that means basically anything, matches anything. Okay, so we have cookie names, we have the value itself. Some of them look like random numbers that are kind of like session ID stuff. Some of them are like user preferences that are just encoded into cookies, so it sticks. You can see different domains, so you can scope it directly to your domain. You can move up a level, down a level. The path is not used at all. We have expiry dates. These are set by the server. Your browser will honor it. You can always override it yourself. Size is whatever, and then secure says only send this over a secure HTTPS connection, and HTTP only says don't send this over some sort of JavaScript initiated connection. Okay, questions about this? Yeah.
What about the bookmarks that we said? The bookmarks, if they have gmail.com. So I shut down my system. I open it after 10 days also, but I can just log in. So how will that cookies be set?
So I missed the first part of your question. So
The bookmarks.
the which?
Bookmarks.
Yeah.
In that, if I save my gmail.com,
Yeah.
if I just log in one time,
Yeah.
then I shut down my system
Okay, you're saying bookmarks, right? So bookmarks don't store, your cookie isn't tied to the bookmark itself. So the bookmark will store the URL of the website itself. The URL now, for reasons we'll talk about next class, sometimes has the session ID in it. And so there could be a connection to cookies that way. But the cookie jar is something like basically when you click the bookmark, it will just take you to that URL. Then your browser is going to go look in its cookie jar, see if it has a matching domain. And if it does, then it will add the cookie to it. Does that answer the question? Okay. Okay, let's see. Okay, so let me I'll go explicitly through what your browser does in terms of the cookie itself. So let's say we go to a website. We'll make it a little more complicated now. And so let's say that this website is going to weave a bunch of resources together from a bunch of different things. Like we saw with ESPN. You saw that there's some, I didn't actually show it, but let me show it. So why are we getting all of these cookies? Like, how is Adobe and Twitter and Google tied into this website? You can see that it's loading a bunch of different resources. Okay, so this website, when it comes down, it's loading CSS files from a bunch of different places. Some of them are coming from things that look like they're ESPN resources. Some of them, like gstatic or Blue Kai, you can see that corresponds to some of the cookies, like Blue Kai here. So they're downloading a bunch of different things from different websites. Okay, so there's images that are coming down. Here's the JavaScript that's coming down. You can see some of it's coming from DoubleClick, some of it's coming from Disney, some of it's coming from Adobe, some of it's coming from Twitter, plus the stuff that's coming from ESPN. Okay, so when your browser downloads the ESPN website and it says, hey, go grab accessenabler.js from Adobe, then that creates a new request. And then now your browser says, okay, do I have any cookies that match Adobe? I'm about to go grab something from Adobe. I wonder if I have any Adobe cookies. If I have Adobe cookies, then I should be putting those into that request. Okay? And so that request goes across with an Adobe cookie. Okay? So that's why you have all these cookies that are involved in a particular website. So yeah, so let's say that we'll just fast forward to you've sent the request. Now you're getting the response back from the website. And it wants you to set a cookie value. Then what you do is you take that response and you parse it. So let's assume that it's HTML, okay? And the response itself is going to say, okay, go grab this image from here, go grab this JavaScript from here, go grab whatever, okay? So what it's going to do is it's going to spawn a bunch of new requests. And each of these requests are going to be checked against your cookie jar. Okay, and it depends where they're going. So it's going to look at the request and it's going to say, okay, well, this first request, it's going back to the same server. Okay. Like based on domain name. And it depends on the cookie, but let's say it's a set exactly to the same scope, then this cookie is going to get inserted into this request. Then the second request might be going to like some other server. and maybe you don't have any cookies for server 2, that's fine. Then there's no cookies that are included in it, okay? It's not going to include this cookie, right? Because this cookie is only sent to server 1. You're downloading an image or something from server 2. You're going to pull it into the website that was sent to you by server 1, but you're not actually requesting it from server 1, so you're not going to send that cookie. You're only going to send it to the actual server itself. And then you look at the next two, and maybe they're both going to the same server. And maybe you have some other cookie in your cookie jar. That your browser puts in that's a cookie for server 3. Okay, so the cookie jar is implementing the cookie policy. And it basically, it walks through the cookie jar and it looks at every cookie in your cookie jar and says, should I include this cookie or not? Okay, so for every cookie, and so it's going to ask itself a bunch of questions about the cookie. So it's going to say, okay, first off, does the domain of the cookie I'm looking at match the domain of where I'm going? Okay. So the domain field of the cookie, which could include wildcards and other things, okay? Does the main field of the cookie match where I'm sending the request to? Okay, so I'm about to ask images.google.com, and I'm looking at a cookie and it's scoped to .google.com, then yeah, that matches, so I should send it, okay? But not quite yet. So I want to check a few other things. Is it expired? I'll phrase it positively. Is it still valid? As in not expired. And then does it match the flags? So if I'm trying to load it over HTTPS or HTTP and it's marked secure, then I shouldn't send it. So do flags prevent me from sending it? Okay, and so if the answer is, let me rephrase this. I'll say if do flags allow me to send. So if the answer is yes, yes, yes to all three questions, then we send the cookie. Otherwise we don't. And so what you do is you for every request, you're going through these 3 steps. So I'm looking at this request here, I go through my cookie jar, and there might be 5 cookies that match. So I might end up sending 5 different cookies that match it, or 10, or whatever the case may be. So as many as match with it, then I send them all. Okay, questions about cookies so far? Yeah.
When you use the option like keep me signed in that case they can use a single cookie for like if I keep my account signed in for like 1 year and use only one cookie for a whole year.
Yep, great question. Okay, so what does that mean, keep me signed in 1 year? What is it, like, what is it on this diagram that controls or not? And so keep me signed in is something that's going to be implemented server side. So it's not something that you're doing, it's not something your browser is going to do any differently. Your browser is going to work the exact same way, but the server is going to change. And usually what the server will do is, there's two options that they can do. One of the options, and they could do both, they're not mutually exclusive. So the one option is in their database, when they have that expiration, they can change what's written there. So they could say, oh, only keep this around for an hour or something like that. The other thing they could do is, this is another like weird kind of question, but let me ask it first. It has nothing to do with the answer to your question quite yet. Could ESPN, so you set, it goes in and sets a bunch of cookies. Can it delete a cookie? Like say it's like, oh, I don't need country anymore. You know, browser, can you delete that cookie? And so the answer is no. So websites can't, it's just like, there's no reason really for it. And it wasn't something that websites really wanted the power to do. And so you can't delete a cookie. But what you can do is you can overwrite it. So you can set it to something new. So probably what would happen is if you were already logged in and you already had a session ID, then Google might overwrite the expiration field of your cookie and make it session, right? It will do that in the opposite case, right? So basically if you say keep me logged in, then it will give you a date. It will give you a cookie that's in a year or whatever. And if you say don't keep me logged in, now it's like by default you are logged in. And you have to actually say, I'm using a public computer. Like that's the prompt I see now more often. And you click that. So it's more like you're opting in to not having the cookie live forever. Then what it's going to do is it's either going to, if it's setting it for the first time, it'll set it as a session cookie. And if it's already set, it will overwrite it. It will give you a new session ID, overwrite it, and call it a session cookie. Yeah. And then when it's a session cookie, your browser stores it. But then as soon as your browser closes, it deletes it. So the next person that sits down and opens the browser, it's gone. And so they're not able to get it. Yeah.
But it won't ask me to like the ID password again, like for 1 year.
If you say keep it logged in, then as long as, okay, so here's another question too. So it's true. As long as you're sitting in the same browser that has that cookie, then it will work. But what if you switch to your phone, right? Then it's going to ask your username and password, right? And if you switch from Chrome to Safari on the same computer, it's going to ask again, right? So yeah, it will keep that cookie jar, like it will keep that logged in essentially. Now, Apple's got fancy and they start syncing things between Safari on your computer and Safari on your phone. I don't know if they sync cookies or not, but presumably they could, so you might actually pick up your phone and already be logged in because you were logged in on your computer. But essentially, if the cookie jar isn't being synced, different cookie jar is a different browser kind of thing. And that would be a different session ID, right? So that's another thing to remember where this table is a little simple because we have a username, password, and one session ID. But in reality, you would have 10 session IDs because you've logged in from 10 different computers, right? So when you reverse index, it doesn't matter because you look up the session ID and then pop off the user. But yeah, so the same user, if you did it the opposite way, you would notice that they have multiple session IDs. And it's possible too that you would have one keep me logged in and another one not keep me logged in and things like that. You can mix and match. Yeah. Okay, so let me show you one last thing, which is you hear about cookies in terms of privacy a lot. So the reason is that cookies can be used to track you. So let me just outline how that works. Okay, so let's just tell the story. So here's Alice. And Alice goes to ESPN.com. Alice doesn't have that setting, prevent third-party tracking, turned on. So what happens, we saw it, she sends a request. Let's say it's new computer, never used it before, private browser mode, whatever. She gets back a response and it immediately sets a cookie. Okay, so now she has her cookie jar. And this cookie is actually not that important to the story, but we'll put it there anyways. Okay, then since she's on ESPN.com, ESPN says, hey, we like to know how users found our website, okay? We'd like to know where they came from. If they came from search, like Google or something, we want to know what search terms they were using. We want to show some ads. Google has a pretty good ad service or something like that. And so what they might do is they might embed some tools that Google gives them. So webmaster tools from Google, okay? Lots of websites do it, something like 80% of websites do it. ESPN does do it, okay? We saw it. We saw its stuff being loaded from google.com here. Okay, and so what will happen is you'll download the website and the HTML will say, okay, go grab this JavaScript file from google.com. So that's fine. Your browser will just go do that. So it will send a request to Google. Be for some like JavaScript file or something like that. And then Google will say, okay, here's the JavaScript you asked for. By the way, I'm going to set a cookie too. I'd like to know who you are. Okay, now ESPN's cookie does not go to Google, okay? But that doesn't mean that ESPN isn't sharing information with Google, okay? They could have some relationship where they share different information across, where they monetize their data and they give it to Google, okay? So Google sets a cookie. Okay, and let's just say that you're on ESPN and whatever, I go to Newcastle United because I really like them as a team, and somehow ESPN is sharing that information with Google. So every time this JavaScript gets loaded into the page, the functionality of the JavaScript asks ESPN, hey, what's the website that the user's looking at? And the website, ESPN's like, okay, that's fine. And Google's like paying them for it, or they're giving them free whatever for in return for it, okay? It doesn't have to have that relationship, but we'll roll with that as an example. So Google's getting kind of the pages, the URL of the page that their stuff is being embedded on that you're looking at, and it knows it's you looking at because it has a cookie tracking you, okay? So that's fine. Then whatever, you're done, you close the browser, and then the next day you go over to Reddit or somewhere, some web form. You send a request, you get a response. Maybe it sets a cookie as well. We can just, everyone sets cookies, so let's just put it in. And let's say that these guys also have a relationship with Google, and let's say they use Adwords, which is a library that lets you serve up advertisements. Google populates the field. Basically, you draw a box and you say, Google, put whatever you want in that box. If anyone clicks on it, then Google will give you a cut of it, okay? So this would be like Webmaster Tools, which is just for keeping track of who's visiting your website and things like that. Whatever Google knows about their users, they'll share with you. And then here you use AdWords, okay? So you get your response back, and the response says, hey, now you have to go over to Google, and we want you to load an ad from Google. Okay, and we're going to assume that when we set the cookie here, that Google sets it for star.google.com, which it's allowed to do. Okay, and so in the background, Google has their own database. I won't draw this. It's getting. Let me draw it down below. Okay, so Google comes here and you send your request, and your browser goes through your cookie jar and says, oh, should I attach any cookies to this request? And it says, oh, there is a Google cookie. It's set to .google.com. Ads.google.com matches that, so that's fine. So I'll append that to the request. Okay, and Google says, hey, I know this cookie. I've seen it before. That's actually the cookie I asked to be set up here, and I have it, I have this cookie in my cookie jar, or in my database of cookies. And I know that when I set the cookie, that user was on ESPN.com. Okay, so because ESPN has a relationship with me, I see all the users that go to ESPN.com. Because the web form also has a relationship with me, I can track them across. So even though ESPN and the web form have nothing to do with each other than the fact that they both embed things from Google, Google gets a ping every time a user goes to either of those websites. Because it can set a cookie, then it can track those pings and say, I'm getting a ping from the same user, okay? Then it can say, maybe I'll show you an ad related to sports, right? Or if ESPN is more verbose with Google and more gossipy and shares more information, it might say, oh, you were looking at Newcastle United, so I'm going to show you an ad for a jersey for Newcastle United, right? That's the ad that I'm going to show you, okay? So this is why you go to Brown Shoes and you're looking at some boots, and then later you go to another website and you see an ad for the exact boots that you were looking at. Or you look at you go to car web pages and then you start seeing car ads everywhere and things like that. It's because you visited two different sites, the site that you're seeing the ad on, and if it's an ad for cars, one of the car sites that you were going to, or the car magazine you were reading or whatever, or just simply Googling about cars, right? Somehow both of those had a relationship with the same ad company. And then that ad company is now linking those two actions together. So like I said, Google's on something like 80% of web pages. I think Facebook is on about 50 or more percentage. And there's other things, ad companies that you haven't heard of because they're not global brands. They just specialize in ads themselves, although they tend to get acquired by big companies like Google. But anyway, so there's basically all the websites that you're going to, there's a 50 to 80% chance that one of these organizations knows at least that you're going to that website. They might know more about what exact content you're looking at on those websites. They're building some sort of dossier about you. It helps them profile you. It helps them send targeted ads to you, and it could, who knows what they'll use it for in the future once like machine learning algorithms like go rampant on them and things like that. Yeah, and so anyway, so something to think about. If you don't like the fact that you're tracking, you could use things like private browsing mode so that you're at least resetting your cookies or just going in and clearing out your cookies. But then that's annoying too, because now you have to re-log into all of your websites, right? You can use things like in Safari, like to turn on the different functionalities like prevent cross-site tracking. That sometimes also breaks websites. Like sometimes I try to log into one website, it redirects you to another. Like TSN, it redirects you to Bell. But then there is a way for them to set up the website, so it shouldn't matter. But the way they choose to set it up, it breaks. And for the longest time, they would like tell you, oh, go like turn off private browsing, turn off all your cookies, turn off, like allow all cookies, turn off do not track, like make sure that you're not have do not track enabled. And they would give you like a list of 5 things, but then at the end they wouldn't say, oh, then when you're done logging in, go turn those stuff back on. So any person who doesn't understand computers, so go through those steps like a recipe. They'll disable all of their web privacy. It will log them in, and then they'll be like, they'll have no privacy from that point forward, for as long as they keep surfing the internet. But anyway, so there is this sort of balance between privacy settings and the functionality of websites. And if you want to do something about the privacy, you're going to pay the price in terms of websites not functioning exactly correctly. And so it's up to you to like choose between the sort of usability and the privacy priorities that you might have. Okay, questions about this? Nope. All right, then we can end a little early, and I'll see you next week. Next week we'll talk about the actual same origin policy, which corresponds to JavaScript.